So we just spent some time learning how to graph basic logarithmic functions by hand. And once we had our graphs up, we wrote down the attributes of the graph, including the domain. Okay, so we were reading the domain strictly off the graph. You can also get the domain of any logarithmic function from its equation. Okay, so way back when, very beginning of the semester, we learned how to find the domain of certain functions from their formulas. We did it for polynomials, we did it for fractions, we did it for square roots and cubed roots. Those are some of the examples. So now we've kind of added to that toolbox. We know the domain of any exponential function is going to be all real numbers. And now it's time to talk about how you find the domain of a logarithmic function from its formula. Okay, there is a very important statement here in red. Okay, we can only take the logarithm of positive numbers, meaning we cannot take the logarithm of any negative number or of zero, okay, regardless of the base. Okay, you cannot take the logarithm of a negative number. You cannot take the logarithm of zero. Okay, if you go to a calculator and just try taking logarithms of negative numbers, okay, watch what happens. Log of -3. You get an error. It says it's not a real answer. Okay, or if I do the log of 0, okay, same thing. Okay, I get an issue. If I do this with ln, the natural log of -9, okay, can't do it. Okay, if I do the natural log of 0, okay, can't do it. Okay, you can only plug in positive numbers. Okay, what's the natural log of 7? Oh, this crazy decimal. Okay, but if I did -7, bad, bad, bad. Okay, so you cannot take the logarithm of any negative number or of 0. Okay, regardless of the base. Okay, so we have 4 functions in example 6, and we're going to find the domain of each function. Okay, so I'm going to walk you through how you're going to do this from the formula. Okay, so this is what you do. Okay, in part A, my function is g of x is equal to the natural log of x minus 1. Okay, the base here is e. That's irrelevant. Okay, what you are worried about, you are worried about plugging in an x value and then simplifying in parentheses and ending up with 0 or something negative, because then if you have something 0 or negative inside the parentheses, you can't take the logarithm of that quantity. Okay, so what to do is you need to take the quantity that you're taking the logarithm of. Here it's x minus 1. You're going to set it strictly greater than 0. Okay, not greater than or equal to, just greater than. Okay, if you put greater than or equal to, you're allowing that quantity to be 0, and you can't take the logarithm of 0. Okay, so you have to take what's inside and set it strictly greater than 0 and solve. Okay, so we're going to solve this for x. Okay, we're going to add 1 to both sides. Remember, you flip the direction of an inequality when you multiply or divide by a negative. That's not what we're doing here. We're adding. Okay, so this tells us the x values that we plug in have to be bigger than 1. Okay, so like, look, if you actually plugged in 1 itself, you would get the natural log of 0. You can't do that. Okay, so that's why the x values have to be strictly bigger than 1. Okay, so the domain here, the x values need to be bigger than 1. Okay, if you wrote this as an interval, okay, you would, if you still need to draw this out, please do it. Okay, here's 1. Okay, your x values cannot be 1, but they need to be bigger than 1. Okay, so that's going to be from 1 excluding 1 to infinity. Okay, so that's the domain. Okay, all right. I'm going to take a minute here to kind of tie this back to the pictures we did when we were graphing. Okay, so I'm going to actually go back to the graphs on the previous page. Okay, so I'm going to start with part A here. Okay, we were dealing with log base 2 of x. Okay, We graphed the function and then we read the domain off of the graph, okay? But now you know how to do it from the formula, okay? So if you are dealing with log base 2 of x, okay, you need to take the quantity that you're taking the logarithm of. Here it's just x. You need to set it strictly greater than 0. Okay, so your x values have to be strictly bigger than 0. In interval notation, that's 0 to infinity. Okay, that matches what we wrote down for our domain here. Okay, if we move on to part B, the light blue graph, okay, we graphed it, we wrote down the domain. We said it's -3 to infinity, okay? So here, if you're doing the same thing and you're trying to read off the domain from the formula, okay, so here's the formula, log base 2 of x plus 3. Who cares what the base is? You're going to take the quantity that you're taking the logarithm of. Here it's x plus 3. You're going to set it strictly greater than 0 and solve. Okay, so I'm going to subtract 3 from both sides. No flipping involved because I'm subtracting. Okay, your x values have to be bigger than -3. Okay, x has to be bigger than -3. That's -3 to infinity. Okay, that's what we got from the picture. Okay, when we went to part C, okay, we had a more complicated formula, okay, because, you know, we had the -1 at the end, okay. So it's going to work the same way, okay. We graphed this function out in orange and we read off the domain. The domain was the same. It's also all x values bigger than -3. So this formula, like I said, is definitely a lot noisier. There's a lot more going on, but you're going to take the quantity that you're taking the logarithm of. Okay, so let me write down the function. You've got log base 2 of x plus 3 minus 1. You're taking the logarithm of x plus 3. You're going to take that quantity, set it greater than 0, and solve. Okay, so you get the same thing, that your x values have to be bigger than -3. Okay, the -1 is irrelevant, log base 2 is irrelevant. Okay, your x values here have to be strictly bigger than -3. Okay, so that's how you can find the domain of a logarithmic function from its formula. Okay, so I'm going to write out the rule right here and then we'll do more practice. Okay, let me put it in a different color so you can see it. Let's put red. Okay, so if you are trying to find the domain of a logarithmic function from its formula, you're going to take the quantity that you're taking the logarithm of. Hey, Dina. Hey, Dina. Can you hear me? Hey. Oh, I'm muted. Hey. I'm muted. Sorry. I was talking to you and you weren't there. Hold on. I got to write something down. Taking the logarithm. Okay, what's up?
Doing?
Can you hear me?
Yes.
Okay.
Hello.
Hey, what's up?
Yeah, I'm almost done with the presentation.
Okay.
So I don't know if I can send it to you so you can like kind of like.
Yeah, send
But
it to
there's
me.
still like, I mean, like there's a lot of things I need to do, like the phone working. Also the slide how it's gonna go. I mean, like this kind of presentation things.
Yeah.
And what else? Yeah, and there's the ending of it also.
Okay. Okay.
I mean,
Yes.
like the information
Send it to me
you
and
can
I
like.
can like go through it and give you some feedback and tell you how you're doing. Because somebody did that yesterday, so I was able to like, um, they had a little mistake in their math, and so I was able to catch that. So yeah, it's a good thing to do that.
Yeah. Okay.
So
All right. So
you can either email it to me, or if it's somebody was having trouble emailing. So if it's too big, I put a Dropbox folder. It says project. That's where you can drop it in there. It's just for me to look at it.
okay.
So if you have
Okay.
trouble,
Fine.
like if it's too big, sometimes it gets too big and you can't email it.
Okay, great then.
Yeah.
All right. So that's in the because I just log in. I haven't seen anything. Is it under my name
Oh, no, no. Like,
or under?
you know how you turn in the test? You know how you turn in the test? Go there.
Oh,
Like under course
yeah.
assignments.
Okay.
Yeah, there's an empty
Oh,
folder.
the assignments, the same thing.
It
Okay.
says project, and you can dump it in there. That way you don't have to worry about emailing it.
Okay,
And I'll
perfect.
take
All
a
right.
look and I'll write a whole big email to you.
Okay.
Okay?
Great then. Okay. Perfect.
Okay.
Okay. Thank you.
You're so
Have a good
welcome.
one.
Okay, you too. Bye, Dina.
Take care.
Bye, you too.